started, does anyone have any announcements? Oh, Alfred, you do? Okay.
Surprising. So next week is the Leo Walsh lectureship, and you might have seen that we have Johannes Lehmann from Cornell here. He'll be here the whole Wednesday. The tradition is that the grad students have lunch with him, so please attend that lunch because Carol ordered food. So besides food, there's also Johannes Lehmann at the lunch. So you can have a nice little discussion with him. If you don't know who Johannes Lehmann is, you Google him and read some of his papers. He just wrote a very nice paper on climate smart soils that very well written and you might be interested in. That's the first announcement. Can I have another one?
Alfred, what time is that on Wednesday?
I think noon, I guess, but yeah.
Julie sent an email asking if anyone wanted to come for the lunch RSVP, and I think she said 22nd. Just let her know until 22nd.
Oh, Julie did send that email?
Yeah.
Oh, okay. So you might have seen also an email from Julie that the department is paying for your Triple SA membership if you would like to become a Triple SA member. And I think it's a very good idea to become a member of a professional society and learn a bit what they do, and there's lots of benefits to it. And if you would like to become a member, you need to fill out the form and give it to Julie. If you're graduating next year, then after that, of course, you have to pay yourself. But whilst you're here, the department pays for your membership. That was all.
Thanks, Alfred. Any other announcements? All right. So we're going to get started. So I'm going to introduce Kavit Krishnan. She is from Mumbai, India. So a little bit about Kavit. She became interested in environmental science when she was in high school, and then she attended the State University of New York, and I was at the State University of New York College of Environmental Science and Forestry. And so there she majored in environmental biology. She minored in renewable energy. She cultivated this interest in agricultural systems. She started working in the RUARC lab in the fall of 2014. And has been working on a project related to cover crops that connects with the large dairy cap project and nitrogen mineralization. So for those that saw one of the original titles float around on nitrogen mineralization, we're going to save that, attend Kavit's master's defense to learn more on that. But so instead, we want to take a little bit different flavor and maybe build on some of the theme that we've kind of built in these seminars. Kate originally gave a seminar a couple semesters ago, or last semester, on some of the issues with nitrogen in sub-Saharan Africa. Kavit decided she wanted to also focus on something on nitrogen and found an interesting topic to discuss that actually I didn't know much about until she brought it to my attention, with some nitrogen fertilizer work going on in India. So with that, I'll turn it over to you, Kavit.
Thank you, Matt. So I'm going to be talking today about neem-coated urea, or the neem way to a more sustainable agricultural practice. And just briefly speaking, I'm going to get into what neem-coated urea is before, because I don't know if any of you have heard of it, but it's basically a nitrification inhibitor, and it's used as a coating around urea. And so just as a quick outline for today's talk, I'm just going to be giving a brief introduction to Indian soils, climates, and the cropping systems. Then we're going to jump into neem-coated urea. What is it? Why is it important enough to talk about today? Does it work? Looking at some of the scientific literature, and then ending up with some of the broader impacts of using neem-coated urea in India. Okay, so I'm going to start us off actually with 2 videos. Just finish up 20 minutes right that way. They're both advertisements.
उत्तम वीर यूरिया के निर्माताओं की नई पेशकश उत्तम नीम यूरिया। नीम यूरिया? ये नीम यूरिया क्या है? भारत में युगों युगों से नीम के गुणों को पहचाना गया है। यूरिया को और भी बेहतर बनाने के लिए नीम के इन्हीं गुणों का इस्तेमाल किया है। यूरिया के दाने दाने पर नीम की सुरक्षात्मक परत चढ़ा दी जाती है, जिससे यूरिया मिट्टी में धीरे धीरे घुलती है और पौधों को जरूरत मुताबिक लंबे अरसे तक जरूरी खुराक मिलती रहती है। धीरे 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 यूरिया फसल लंबा पोषण पाए। यूरिया आग में बचत फसले तंदुरुस्त पैदावार बढ़ाए उत्तम नीम यूरिया
So that was an advertisement by a fertilizer company in India that was trying to convince farmers to buy neem-coated urea in the hopes that it would increase yield and that it would also allow for a slower release of nitrogen. This is an advertisement by the government of India, actually, also a neem-coated urea.
सुनो सुनो किसान भाइयों सुनो सुनो ओ सुनो सुनो किसान भाइयों सुनो 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 किसान भाइयों ध्यान लगाकर बात सुनो नीम कोटेड यूरिया आया खेती में नई क्रांति लाया इससे
Not entirely sure what happened with that.
Lost in a second.
It's potentially lost the internet. I have a smaller version of it on screen, so let's try with that.
सुनो सुनो किसान भाइयों ध्यान लगाकर बात सुनो नीम कोटेड यूरिया आया खेती में नई क्रांति लाया
Lots of new innovations in farming. And they talk about how the plant gets nitrogen better.
तो भाइयों नीम कोटेड यूरिया से हो मेहनत सफल बेहतर हो खेत पानी और फसल कृषि और किसान कल्याण मंत्रालय द्वारा किसान हित में जारी
So yeah, that was a Ministry of Agriculture and Farmers Welfare talking about how neem-coated urea was going to supply nitrogen to the plants better, improved groundwater, and killed pests. So let's see if I can get it to go further. Delay problem Okay. We shall hopefully soldier on. Okay. So looking briefly at land use in India, you can see over 60% of India is arable land, and it's all the yellow. The green is the forest, and the little purple is just basically scrub and grass. So huge portion of India is under cropland. And as a brief idea, here's a soil map of India. So again, you can see a lot of alpha sols, a bunch of vertisols, some iridosols, ultisols, and septisols, but obviously alpha sols dominating the landscape there. There are two main cropping systems in India, the Kharif and the Rabi. So Kharif, you have rice, maize, cotton, all being grown from June to October. You have the Rabi cropping season, which is November to April, and there you have wheat, barley, some mustard, a bunch of pulses. And then finally, a much shorter growing season in the summer, from March to June, which is just a few horticultural crops, cucumbers, watermelons, bitter gourds, stuff like that. And to quickly familiarize you with the crops that are grown, so the map on this site is just basically looking at the first ranking crops in India, so the ones that is grown most in that particular region. And again, you see a lot of rice, which is the dark black. Then you have wheat a little bit in here, but a lot of wheat is also intercropped with rice, as we saw previously. You have jowar and bajra, which is actually just sorghum and pearl millet, and finger millet, which is ragi. So a lot of cereals that are being grown in India. And as a brief idea, also in terms of water, the map on the right is looking at irrigation use. And the blue is the areas that are majorly irrigated, so actually a very small portion of India. And over 60% of that is actually rain dependent, so the reds and the yellows. So yeah, a lot of rain is being used. So why urea? 82% of nitrogen application in India is actually urea. So most of that nitrogen is coming from urea. And in fact, of the total world, urea consumption, India accounts for close to 18% of all that urea. And compared to the United States, you can see much more is being consumed. Okay, so we're gonna jump into neem. Azadirachta indica. It's basically an evergreen tree that's grown in India. It's got medicinal properties. It's been used in India for timber for a long time. And it has a great deal of cultural significance too. So you'll find it growing in villages and by temples just because it's considered a bit of a sacred tree. And it is native to the Indian subcontinent. So if you go back to some of the early observations, farmers were using neem, almost like a neem cake, just using the leaves and the seeds as a fertilizer for many years. And this was based purely on observation, but it was assumed that it could be used as fertilizer. And so it wasn't until the 1910s, 1920s when initial studies on neem started, and they started to isolate some of the chemical compounds that could be found in this tree. And in the 1960s is when people discovered that it had possible bioinsecticide properties. So that led to a much greater push to isolate the chemical constituents and figure out which of those chemical compounds could have agronomic benefits. So 1970s, you started seeing a lot of studies that looked at neem extract, usually mixed with acetone and mixed with urea. And they were comparing it to sulfur-coated urea or slow-release fertilizers, as well as nitrification inhibitors. So at that point, they were seeing that they had similar results with these slow-release and nitrification inhibitors, but they still weren't sure what the neem was actually doing. And it was in the 1980s when milicians, which was a chemical group of chemical compounds that had been discovered earlier, which in the 1980s they identified as having nitrification inhibition properties. So that's when you start seeing a lot of studies looking at how neem oil can be used as a nitrification inhibitor with urea. So just processing the neem-coated urea, it's actually the seeds that is used to get the oil. And there are two main ways. You can either crush and cold process it, or there's a solvent extraction in which it is heated up a little. You have a coating that's made, which is just basically the neem oil and a bit of the neem oil that is concentrated to form a neem extract. So it's just an extract, it's just a concentrated neem bitter. And then that's mixed with a binder or an organic solvent. And then that entire coating is mixed with the urea at about 1% of the weight of the total urea. And the picture isn't particularly clear, but you can kind of see the white urea, and it forms a brownish kind of coating over it. Okay, so looking at just basically the rate of nitrification. So the specific compounds, like I said before, are milicians, and it's kind of tritterpene. I'm not going to get into the chemical compound, but it is out there. And what it has been shown to do is inhibit nitrification by reducing the population of nitrifying bacteria. And as a quick reminder for everybody, nitrification is just basically the process of ammonia being converted to nitrate, and you have like nitrite in the middle and nitrous ammonius and nitrobacter. So those are the populations that it's going to be affecting. Okay. So looking at one of the early studies, this was in 1991. And what it was looking was the total concentrations of nitrate and nitrites in an incubation study between Pearl's urea and neem-coated urea. So maybe this would actually be a little better. The one over here, the dashed line right in the middle, is neem-coated urea in an aerobic condition. This dark line is under flooded conditions. And over here, this one is Pearl's urea. So basically uncoated urea under, again, aerobic conditions. And this last black line up here is Pearl's urea under flooded conditions. And again, the reason they're looking at this in flooded conditions is because rice and wheat dominates most of the Indian landscape. So for rice, a lot of these areas are flooded. And what you can see is that there is a definitely lower concentrations of nitrate and nitrites that are seen almost throughout the incubation, but definitely in the first 30 days for the neem-coated urea. There's also a much gradual release. There's obviously a very sharp rise in concentration over here with the Pearl's urea, as opposed to the neem-coated urea, which is more of a gradual increase. And yeah, so like I said, for the first 30 days, we see definitely significant results, and then the concentration of nitrate and nitrite decreases for all of them, so not too different. And again, we see some slight slightly higher concentrations of nitrate and nitrite in the flooded conditions. So this was just looking at their studies, and they calculated the nitrification inhibition percent of both the proteinuria and the neem-coated urea. And the previous study was done in altosalts. They also looked and see if it was consistent in vertisalts as well. And again, you see that there was a significant difference for the. So basically, the nitrification inhibition is the difference in proteinuria concentrations of nitrate and nitrite and the neem-coated urea concentrations. And they found pretty large percents of nitrification inhibition, and they were definitely significant. So, what they also tested was the urea percent of urea nitrogen that was hydrolyzed, just to see if it was having an effect on the urea itself. If either it was acting as a slow release and coating the urea, preventing water from getting in, or if it was affecting the urease enzyme, and they found no significant differences. They found for both by around 3 days, 100% of the urea was being hydrolyzed, so they were